Okay, thank you. It's a privilege to be here. Today I will talk about water resource management in Africa from space. This April we are celebrating the 35th year anniversary of the We Are the World song, which raised funding to support the famine relief efforts in Africa, primarily in Ethiopia. It's very unfortunate that 35 years later they are still raising money for famine relief, and this is too personal to me because I lost a lot of relatives during this famine, and as I said, the situation only got worse. It changes places, it changes times, but the situation is getting worse. This slide shows the access to power in Africa, to energy. So you can see that about more than 75% of the people do not have access to electricity in most places. In terms of access to drinking water, the story is the same. If you look at these warm colors, less than 40% of the people have access to drinking water, safe and clean water. So in terms of water, in terms of food, in terms of energy, we still have, these issues. And globally, you could see that in terms of drinking water, 844 million people lack access to safe drinking water. In terms of food, uh, similar figure. They lack access to food on a daily basis. In terms of energy, about 1.1 billion people. And the situation will only get worse with time. Uh, the problem is going to accelerate by 80% in a few decades, by 55% in terms of access to drinking water by a few decades, and in terms of access to food by 60% in a few decades. And the key in all these cases is water. So what are the challenges with water resources? One, we have this inequality. So some areas, they have a lot of water, they use a lot of water. In some other regions, no, that's not the case. There is unfair water allocation. When we have resources, especially in Africa, we have non-sustainable consumption. And then on top of that, we have extremes, meaning, we have floods and droughts, etc. And then climate change imposes what is called non-stationarity. So things are also changing with climate. And on top of all these issues, we don't have, especially in Africa, we did not have any data to be able to even know how much water do we have, how are we using it. So that is a challenge. Now, there is a big opportunity, and that is satellite remote sensing. So although this technology started developing during the Second World War, it is really over the last 10 years or so, it has really becoming mature and useful to society. Uh, the problem is will only get worse in the future because this is climate change. You can see that regardless of what scenario we are looking at, uh, we are going to see temperature rising, and that would have an impact on, of course, the resources. Also, if you look at population growth, look at Africa. The population growth is going to be it's going to be a big challenge. If we cannot feed the number of mouths we have now, how are we going to feed them when we have, twice of the figure we have in a few years? So this is, is a big challenge. So what we'd like to do is, how are we going to adapt to problems or to situations that come because of climate change? This would have an impact on water resources, on energy, and on food. So the solution that we are going to develop, it should be able to somehow decrease the water demand because we have fixed resources. We should be able to somehow increase supplies in various ways. We should be able to basically smooth out the variation either in time or in space, and we should be able also to transport water from where it is to where it does not exist in various mechanisms. So here I'm showing you an example of the impact of climate change. This is a Red Sea region. So if you look at the 40-year climatological rainfall map, you see that most of the rainfall here is more than 2,000 millimeter. So most of it is located in some highlands, right? So we can see Congo, Nile, etc. Whereas, the other regions are relatively dry. Now, what is happening to this situation? So if you look at the trend in rainfall, you can see that wherever we see a lot of rainfall, especially in the Ethiopian highland, so this is the Nile Basin, so we are going to get more and more rainfall. So the total rainfall amount is not going to decrease. It's actually going to increase based on our measurement for the past 40 years. But there are some locations here where we also anticipate a reduction in rainfall. So the story here is when we talk about climate change, it really varies spatially. So we really have to take that into account. So here what we did was we looked at the trend in different seasons. So this is summer and this is spring. So if you look at summer, we only see increase in precipitation, right? The major reduction we see in precipitation is during the spring. And this has huge impact because regions like this, for example, they usually have two agricultural seasons, one in the spring and the other one in the summer. And typically they get less rainfall in the spring. Now, if that less rainfall is gone, they will be forced to shift from two cropping seasons to one cropping season. So you can see that the impact of climate change, it really varies not only spatially, but also which season you're looking at. This is groundwater storage from GRACE satellite. You can see that, so blue indicates increasing groundwater level, and these colors indicate reduction in groundwater. So you can see that in most places, especially in the dry parts of the continent, we are seeing less and less water storage. However, in the highlands here, in the highlands of East Africa, we see that there is gradual increase in water storage because the rainfall is increasing and people are not using existing water resources. So in general, if we have to come up with a solution, we need monitoring and forecasting tools. So these were unthinkable 20, 30 years ago because the sensor network we have in Ethiopia and everywhere in Africa was pretty much non-existent. But thanks to satellite technologies and models, we have now opportunity to develop reliable monitoring and forecasting tools. So we have, as I said, great opportunity to monitor water space, specifically from space. So what would be the advantage of this? So this data are available globally. This is a huge advantage. It's available almost near real time. So if you go to the website now, you will be able to see some of the data that happened like half an hour ago. This is a huge advantage. Even when we had all these stream flow networks, weather stations, etc. Although we had this in Africa, but the problem is, in some cases, it takes years to even see the data. So the data are pretty much useless because nobody can see them in time frames that are useful for operation. But satellites are going to overcome that challenge. The other big advantage is most of the data are free of charge. So when we are talking about water resource data, especially most of the data are free of charge. And over the past 10 years or so, the accuracy of the data has really increased. And this is really ideal in transboundary basins. The challenge in Africa is not that they not only have limited ground-based data, but they are not willing to share data. So data is, is considered some secret information, etc. So especially when you have transboundary issues, then that's a big problem. But with satellite, essentially this problem is gone. So satellites are going to provide unique opportunities, especially to Africa, to increase informational water resources. But the forecasting technology has also substantially improved. So satellites can only tell you what is happening, but these forecasters, they can tell you what's going to happen in the future. So in the past, the forecasting capability was limited. Most of the forecasts were qualitative, they were very subjective, but now we have developed quantitative forecasters, and the accuracy has been really improving over the past 10 years. And the good thing is most of these forecasts are available globally as well. And when I say forecasters, I'm talking about lead times from few hours to years. Okay, so I believe that given the technology of satellites and models, we should be able to really know what is happening in terms of water resources. And I'm going to show you an example. This is precipitation from space. I downloaded this imagery last night. So I'm going to show you. So this shows you the rainfall rate every half an hour, for every 10 kilometer by 10 kilometer space on Earth. So this is amazing, right? So as I said, I just downloaded this last night, so you can get data pretty much in real time. This is an example, but I could show you the same thing for soil moisture, crop water requirement, vegetation health, crop yield, etc. So the list is really long. Now, there's another exciting satellite that's going to be launched soon. So far, we have not been able to measure the water level and river discharge, especially for big rivers. But we have now NASA's SWOT satellite, which is going to be launched exactly a year from now. When this is launched, this is going to make huge impact. For example, if we have reservoirs, we should be able to tell the reservoir level. For big rivers, we should be able to tell the stream flow. So this technology is coming up next year. In terms of forecasting here, I'm showing you some examples. This is for lead time 1 day Africa. This is 5 days, 10 days, 15 days, a month, 2 months, 3 months, 4 months, etc. So we have this kind of capabilities now. So the opportunity is there, but there is also research need. Something has to be done to be able to capitalize on these opportunities. And what are this? Well, we have lots of satellite products. Which products do we have to use? How accurate are they? What would be the best way to use the data so that we can solve societal problems? And how can we make this scientific information accessible to policymakers, end users, decision makers? So these are research needs that we are currently working on. So I'm going to show you some of our solutions as an example. So we developed a decision support system for hydropower reservoir operation in Africa. The issue there is just quickly, the total amount of power generated in Africa is too low. It is the same as, say, what one country in Europe, say Belgium, generates, or what Vietnam generates. So the power is very, very low. And the problem is pretty much all the power is coming from water, from hydropower dams. But the efficiency of these dams is very low. In most cases, it's under 30%. So if a dam is designed to generate, let's say, 1,000 megawatts, but in reality, it generates less than 300 megawatts. So this is a huge problem. And the problem is the way we operate the reservoir, it does not take into account forecasters. So we have no idea. So the decision makers have no idea what's going to happen in the future. They make decisions on how much water they release today, based on their knowledge of today. And that approach seems not a sustainable way and not a scientific way. So what we did was we developed a decision support system. So we are using the climate forecasters, and then we convert them to water reservoir inflow. And then we also use optimization systems. So if you have X amount of water available, what would be the best way to release this so that you can maximize power production? So that's our sort of decision support system. And within each component, we have done extensive research to make sure that each component works fine. Here's just an example. So one thing we did was how reliable are our precipitation products that are available from space. So this is the Blue Nile Basin, where we had our own extensive network to test the quality of the satellite data. So based on our decision support system, we were able to show that our decision support system can increase the power production in Africa by 40%. So this is huge. So without doing any physical infrastructure, by just deciding how much water to lose, to release from the reservoir for power generation, you can actually make significant impact to the power generation in Africa. So the problem we have in Africa is not lack of resources, is not lack of water. It is really lack of scientific information, right? So if we have scientific information, we can do a lot. So in this case, I'm showing an example for Gibe hydropower dam. In a typical year, it's generated about 0.54 megawatt, but by using this decision support system, we could easily generate 0.76 megawatts. And of course, the next issue is how can you make this scientific information available to users? So here we developed a visualization module, for example. In this case, people can use this graphics. They can specify whether they want forecast or monitoring data, what is a time scale, what is a time period, and which satellite product or which model, and then they can download data, etc. So this is an example of what we did for Ethiopia, but we are currently working on East Africa and other basins. Now, this kind of information is of course useful for a given dam, but it's actually much more important, especially when you have transboundary water issues. As you know, the GERD issue is now in the news frequently. There's huge concern that the countries may go to war. It's a huge problem. And usually the problem is we have reservoirs in this area, in this basin. And the issue is what is the best way of using, managing the reservoirs. So one of the issues where these countries cannot agree is this dam, the Grand Ethiopian Renaissance Dam. So there's a disagreement on what is the best way to fill the dam. So the dam is almost empty now. For example, Ethiopia wants to fill the dam in a shorter period of years. Egypt or Sudan might want to fill the dam in longer period of years, etc. But the issue really here is, if you have a scientific tool, it should not be that much difficult to come up with a situation, with a solution that would be useful to manage the reservoirs in this basin. So for this kind of reservoir management, it's very important to rely on scientific information, which is available to all the stakeholders. So one of the issues here is, Egypt has access to her own, to its own data. Ethiopia has access only to its own data. They don't share data, and etc. That's a huge issue. But with satellites, etc., you don't need this kind of agreement, because the data is available. So this kind of support tool will also help avert conflicts and other problems. We are currently developing the decision support system for major hydropower dams all over Africa, but the strategy is the same. That technology that I mentioned to you, the monitoring and the forecasting, it is applicable in not just for hydropower, but in any sector that utilizes water. And here's an example of irrigation. With that technology, it's possible to improve irrigation efficiency. For example, one thing that we find out now is the way, the efficiency of dams for irrigating land is actually even much lower than the efficiency of hydropower. So usually reservoir managers, they have static rule. So they might say, for example, every 10 days, release X amount of water. The problem with that is, well, if there is rain, that system does not take that into account. So that's a loss, right? Whether there is a rain or not, they usually supply that amount of water. So they don't have any dynamic decision support system that takes into account these issues. We are currently working on another project, which is, forecasting drought in Africa for various lead times. So the take-home message here is it's a lack of scientific information. It used to be a huge issue, especially in Africa. Um, Comparatively, the issue is not of that important in the US and Europe, because in US and Europe, we have extensive ground-based sensors, extensive sensors. But within Africa, those sensors, have been lacking. But because of satellite data, we have access to significant extent scientific information. This information, as I just showed you through our example, it can substantially improve water resource management, agriculture, hydropower, etc. However, we need to be able to generate this scientific information and make it available to users. Thank you very much.